In this video of StressOff, we are going to use Calculix as the software to conduct finite element analysis of a 1 cubic meter of steel cube. Now, we already had created the mesh file when we conducted the finite element analysis using Salome Mecca. So this is the mesh file that we had exported as UNV file. So I'm going to copy this and create a new folder called Calculix and just create a new case. I'll save it here. So the mesh file has been already added to the project folder. So after we copy the mesh file in here, we are going to go in and select the mesh file and we want to convert it. So let's just go to the case file and open up the mesh. Now what's happening is Calculix is complaining that there are spaces in the path. So how about we just go back and rename this folder. Let's try it one more time. So the file is here. Let's go in and try it again. Now Calculix is not complaining. So one important thing that we learned today is that there should not be any spaces. Well, it's already written here, but again, by default, sometimes you forget. So we have got the UNV file selected in the launcher. Let's convert that file. Calculix made it very easy for us. Now the mesh_1_out file has been created. So after the output file has been created, we don't need launcher. We will go to input editor and we'll open the input file in here. Now the entire input file is shown here. What I am interested mostly in is to find out if the nodes that we had created, like the press node group and also the displacement groups that we created, are in there or not. As we can see here, the node set of press is there, node set of EZ0. So what Calculix does is, if we write DZ, it changes it to EZ. So the node set of EZ0 is there, EY0 is there, and EX0 is also there. Now the element set, one thing I would like to change here is the element set name. Let's just call it all, as in all elements. After we do that, let's save this output file. The first thing that we need to do is to add a material. Now here we are just going to use an elastic material. We'll call this material as carbon steel, CS. Young's modulus is 2.1 E5 and Poisson's ratio is 0.3. Now we will not worry about the density for the time being, so I'm going to delete all of that. Next, I'm going to add section. It's a solid section. The material name is carbon steel, what we just defined here, and the element set is all, because we want this material to be added to all of the elements. After this is done, we can go in and add a step. Now we are going to add static linear step to the file. After we do that, we can see several different things that are added. Step is static. Now it is asking us for the boundary conditions and loads. We haven't added any boundary conditions, so let's go in and add the first boundary condition. So we go to template, boundary conditions, and zero displacement boundary condition. The node group that we want to first give boundary condition is EZ0, and the direction, fixed direction that we want is direction number 3. Now after we have added this, let's just add another boundary condition for pressure. So let's go in and we add a pressure to body. Now yes, we'll need to save this, so yes, I would like to save it. The group name is press and the pressure value I want is 1 megapascal. I'll say OK to it. So what Calculix did is it added a surface and then it added the load or the pressure of 1 megapascal on that surface. Now the file is ready. Before we run any analysis, we'll save this file and then Calculix run solver. Now again, job finished very quickly because it's a very small analysis that needs to be done. So let's go in and check the post-processing for this. I'll just make sure that Z is pointing vertically up. And then let's go in and say or look at the displacement data set. Now we are particularly interested in D3 or displacement in Z direction. As we can see here, the displacement we are getting is minus 4.76 micrometers. We can also check displacement for all of the 3 conditions, but let's go in and check one Mises stresses. As you can see, for the one Mises stresses, the stress is consistent 1 megapascal throughout the entire cube. Now this finishes the first boundary condition where only the bottom face had 0 for Z direction. Now let's go in and save this file as case 02. And what we are going to do is we are going to change and add EX0 and EY0 boundary condition as 0 as well for all of them. Now let's go in and run the solver. My mistake. We need the pressure.sir and pressure.dlo in it. So let's go in and add these two to case 2, and then let's try to run the solver again. Job finished again, and when we check the post-processing parameters, again let's go to Z up and let's check displacement predominantly in Z direction. The maximum displacement is negative 4.79 micrometers, and for the stresses, for one Mises stresses, we have 1.34, and that is wrong. It is wrong because we have said EY equals to 1 as well. So let's go back in, quit this, make this EY2 because we want to restrict EY0 in Y direction. Let's go in and run the solver again, and let's look at the post-processing module. Again, let's quickly check displacement in Z direction, minus 4.76 micrometers, and stresses, that too, one Mises are 1 megapascal throughout. Now let's go in and save this file again. File, save as. Let's create a case 3. And first, before I forget, let's just copy these two, the surface and the pressure or the load in here. And then for the bottom face, let's just add all three boundary conditions to it. So it is rigidly fixed. Let's just run this solver. Again, job finished very quickly. And when we post-process this, we can see that the maximum displacement we are getting is 4.75 micrometers on the top face, and for the stresses or von Mises stresses, we are getting 1.21 megapascal, and that too, it is only at the edges, as was clear in the other softwares. Now the bottom face in the middle section, we can see that the minimum stress is 0.524 megapascals. The maximum and minimum stresses are also displayed here. So the minimum stress is 0.524 megapascals at node 300. Similarly, we can see for displacement as well what is the maximum and minimum displacement. So this concludes the analysis of 1 cubic meter steel cube. If you liked it, stay with us, give your comments, and we'll try to use as many softwares as we can so you get an understanding of how to conduct finite element analysis using a particular software. Now, if you like this video, also there are other videos which you can check out in the links that are provided. And also, I would like to thank all who have already given comments to us. Thank you all.